Good morning and welcome to Race Industry Now, the weekly webinar series from Trade, presented to you by ARP, Performance Plus Global Logistics, PIC, Feria Racing Components, and Fifth Third Bank Motorsports. I am Francisque Savignan, the founder and CEO of Trade, the racing industry, every minute, every day. This is episode 452. Due to a last-minute issues, UEM have been unable to present the webinar today, but fortunately, their guests, Line-to-Line Coatings and Total Seal, have been able to join us. So we're going to be hosting a webinar with Total Seal and Line-to-Line Coating, and we're very thankful for them to step in. And we will reschedule the tech webinar that was originally scheduled for UEM on diesel piston performance later this year. With me this morning are Judy King, the co-founder of Trade, and a wonderful host, Mr. Jeff Hammond. So, Judy, we have a big news today.
Well, thank you, Francisque, and thank you, everyone, for joining us. Happy birthday to us. 6 years. Can you believe that, Jeff? 6 years. Because you knew when we were launching this company. And, you know, it's great to see how the industry has embraced both buyers and suppliers using this platform. There's a new way of doing business. They believe in us, and we're just giving them the good old-fashioned customer service we used to at our old days at PRI. In the past 6 years, we've generated thousands of leads, created dealers, connected businesses, evolved, produced educational content. You know, Jeff, you're part of that. And then showcased products and services, thousands of new ones to our industry. And then the cherry on the cake is co-producing Race Industry Week, where we bring on the titans of the industries in all forms of racing. So, whew, I'm exhausted. Jeff?
Yeah, but you're only 6 years old, so you got a lot of life in front of you. No, it's been an honor to be a part of the adventure that we've gone through. We've gone through the great growing pains. We've realized the deficiencies within the company. We've adjusted those, and the fact that I guess you might say the whole industry has embraced us and helped us, you know, become who we are. And I think that's speaks volumes to y'all's idea and all of your persistence and the years of being committed to the motorsports industry. And like I said earlier, I'm very proud, and I know Brad Gilley, he and I both just feel honored to have been selected or allowed to be a part of this growth and get an opportunity to meet all these great companies that believe in us now. And like these gentlemen are coming on here now, I've talked to them before, and it's always a learning curve and a lot of information. And I'm really excited about having them here today once again. And let's see what we can learn today, guys. Good morning, everybody.
Good morning.
Morning.
Y'all doing well?
Yes, sir. It's been a busy couple days trying to put a plan together here, but I think we got some good content, and we got Keith from Total Seal to shed some light on, you know, a lot of stuff related to ring seal. So we're excited.
I'm gonna back up here just a little bit, and I feel like, you know, this is maybe unnecessary, and guys, I'll stop as quickly as I open my mouth if I go down a path you don't want to talk about. But what I find interesting about rings, piston rings, is everybody thinks that piston rings came along when the automobile was developed. But rings were actually in the history of this country long before that. And it was doing a service back when steam was the primary way of making power and, you know, and making products to a certain degree. Am I right about that?
Oh yeah, absolutely. Piston ring was invented by John Ramsbottom. I want to say it was mid 1800s, and absolutely it was steam driven. You know, there was actually times where it was used as a water driven seal for a water driven piston. Water wheel systems that were, we'll say, hydraulically trying to seal and do that same thing, but with a liquid, not a vaporous, material like steam. So yeah, they've been in use in lots of things, and they get used in lots of things. It's not just, when we say, a piston ring, we're not just talking, automotive applications. Think of shock seals, transmission seals, hydraulic seals, pneumatic seals. That little round piece of metal, or in some cases, Teflons and nylons, get used in lots of things, all kinds of things from, we'll say, air compressors to pumps to, all kinds of things that those get used in.
Well, and again, I just wanted to make people understand and really realize that, you know, the automotive industry is definitely, you know, the leading probably user of piston rings in today's society. Maybe not. But the thing is, the progress that has been made since the middle 1800s and the, you know, leaps and the bounds of coatings that go with all this stuff. There's so much that has been developed. To me, when I was sitting there, you know, kind of reviewing things, it just opened my eyes how lucky we are that companies like yourselves that have taken kind of like the challenge to come up with a better way to make all this stuff work and help reduce drag and proficiency and everything, durability. And I think today, you know, we're going to learn some more. So I know you've got, I know y'all been crunching here lately to make sure we have a program today, and a good one at that. I got an opportunity to look through the slides. So you guys just, you know, take over and lead us down the path of more knowledge and kind of get us caught up with what you've developed since the last time we've talked.
We're looking forward to it. Like I say, it's kind of a whole, and thanks to Andy for putting together a presentation kind of on, you know, on the fly. This kind of, as we said, things got changed a little bit. That'll get revisited later. So, you know, hopefully we've got some good information for all the viewers and listeners, and we can put, you know, forth a good presentation.
So
Well, who's going to ramrod this thing?
I think it's Andy.
Yeah, I'm gonna give it a whirl here. Every time I try and do this stuff, the instructions are different. So let's see if I can just get
Well,
to.
I'm going to say, Andy, you pushed the right button at least to start with.
I'm trying to get the slideshow and my.
Over to the far left.
Well, the other thing is over top of it. There we go. Okay. Slideshow. Okay, there we go.
Oh, I love
Always interesting.
Andy's like,
I'm going to say drum roll, drum
Hey,
roll.
put some
Yeah.
How do I share my screen? Not a clue.
So that's neat. E-Part Trade is hitting 6 years right now. Just on Monday, I think our 10,000th job came into our Michigan location. So that's since 2008. And it's going to be a long time before we can add another 0. So we're going to celebrate a bit. But just want to thank everybody, customers, you know, help us with feedback. People like Keith and the UEM guy, you know, everybody's trying to make people's engines work, and we work together to do that. And so, you know, our staff here, and then Line to Line Southeast, Brian Neal has been amazing with his networking and his quality, and Chris Borwick out west, and UEM got us into high volume remanufacturing, and that was an exciting goal. And then Total Seal, man, when they started referring people our way, we didn't have to explain it anymore. People just called and said, I want it because Total Seal said so. And what an inflection point that was for us. But so now to jump into some, well, my down button didn't work. Why isn't my, okay, I guess I'll do it that way. So like Keith mentioned, lots of different kinds of pistons. They're all different, but they're all kind of the same. They're sealing something, transmitting power, keeping the fire or the steam up top and the lubricants in the bottom. And the rings are a critical part of that equation. So when we had this opportunity to kind of hijack the webinar, we thought, well, Keith's here, you know, we get all this feedback. We don't really know, we know we're helping, but we don't know how. So I read the other night, I listed all this feedback we get, and Keith said he came up with the keyword for this webinar. But some of the stuff we've heard over the years, you know, we get higher compression, it lasts longer. Well, it stopped smoking finally, it stopped burning oil. Better pan vacuum for race guys, less blow by, less noise, quieter operation, and just a smoother feel. You know, guys will tell us, man, I'm never going to build an engine without that coating again. So then you go into leak down and, more consistency between your cylinders. On a multi-cylinder engine, your leak down numbers are crunched into a narrower band. And then it lasts longer. Second rings are sharp. Sometimes on the ends of the second ring, you see it, the wear pattern widens up, and that's because the rings are moving around and taking that shape. People go, hey man, my spark plugs are clean for the first time ever. So I took ring tension out and they're still clean. We're just going, why are they saying all this? And Keith came up with exactly the answer. It's ring stability through piston stability. So this is our first little slide, and I'm just going to rip through these slides, a couple of them anyway, and then I'll slow down. But Rafa Matos won the TA2 in 2018. He ran this piston 4 times on that race circuit, won 3 of those races, and you can see it looks beautiful. The entire skirt is engaged. The ring, if you can look at the second ring, it's just the slightest little wear ring. That thing's still scraping the oil. And there's a question right off the bat for Keith. You got the compression ring up top, you got the oil ring on the bottom for returning and scraping. What is the second ring? Is it compression? Is it scrape?
Well, you left out one more. Or is it both? And it's both. It does both jobs. I'll tell anybody, I get a lot of people, it's like, oh, I look at this, this Formula One engine from, 2005 or whatever year it was, and it's got a 2-ring piston. And I see this little Briggs & Stratton, and it's got a 2-ring piston. You don't need that second ring. And I said, well, take your small Chevy and pull that second ring out and see what happens. I said, because the blow-by is going to go through the roof and the oil control's out the window. And what we're doing is, can a 2-ring piston work? Yeah, a 2-ring piston work, but it's got to work in an environment that it was designed around. So when we've got a clean sheet of paper engine, and we designed the specific amount of oil volume that's being moved around in this engine, because it's all about windage. It's all about, how much splash, how much oil is being thrown around in this engine, how much oil is coming out of the cam tunnel, how much is squeaking out around the lifter bodies, how much is coming out, so here's something to think about, folks. Where does the oil come from? Well, it comes from the bottom end. Okay, well, so we take an engine and we increase the oil pump volume. Well, now we're trying to squirt more oil out through the bearings. So oil pack pump through the bearing clearance to the crank, through the connecting rod side clearance. We start modifying things, radiuses and chamfers on the cheek of the rod. These all affect oil volume, and we start putting more oil into the bore. So we're asking the oil ring to do the job. We're asking the compression ring to do its job, and neither one of it can do it completely in that engine that's got so much volume flying around. That's the second ring's job. It's there to back up the oil ring and to back up the top ring, to catch compression that the top ring misses. Now, in a clean sheet of paper engine, where I started with, where we've really got everything under control. Yeah, you can get a ring with a 2-ring piston, but most of the time when we go to a 2-ringer, it's simply because we've got a packaging problem. We've got a compression height issue. We've got, not enough area to cram 3 rings in, simply won't fit. So we sacrifice a little with 2 rings. I've never seen a 2-ring piston that worked better than a 3-ring piston. So bottom line, second ring's there to back up the top ring and to back up the oil ring. It's there to catch what both of them miss.
Awesome, thanks. So the other night when Keith and I were talking, he answered the whole question, all my list, with one word. And he said, that's piston stability. So, and that makes a lot of sense. We talk about how the self-fitting coatings allow you to run the very largest effective piston skirt in each bore. And that means it's taking up space that otherwise would be open. And that open space is where the piston can rattle around. And then your rings are rattling around with the piston and you lose the seal. So over the years, we've kind of come up with this, everybody measures, yeah, my clearance has to be 5 thousandths. Well, that's at the gauge point. What should it be 25 degrees off the gauge point? What should it be a little bit above? And that's where the profiling magic and cam piston development magic happens. But the coatings, if you just build it too tight, it will wear in safely until it's right. So like integrated skirt clearance is the envelope of slop that allows the pistons to rattle. So to kind of, for the concept, if you flattened out your piston skirt, drew little squares like this drawing, you can see your gauge point there. Well, each of those squares has a clearance. So if you measured from the middle point of that out to your bore and multiplied the area times the clearance, you get a volume for each of those spots. And that's what we want to reduce as much as possible without causing scuffs or elevated friction or other motion problems. So, you know, the red spot is what everybody's talking about when they go, yeah, I need 5 thousandths, but all that yellow and green is really important to settling the piston down. In terms of rock, you know, you've got torsional stuff and harmonics, all kinds of different, you know, and even front to back in a motor, the crankshaft is moving a little bit. And if you can stabilize all those motions, your rings just have a much easier job. So integrated skirt clearance. So then we've used these slides before, you know, it just shows the gap. You know, do you want to ride on one little spot or a whole curved band that's gonna cuddle the piston from, you know, longitudinal motion? So all that. And then if we go to this next one on the left there, you see that's where the integrated skirt clearance is allowing that piston to rock. And if you take it up on the right with a coating, then your piston can't rock and your rings don't have to move so much. Oil films are stable. Another nice thing about the integrated skirt clearance, Keith alluded to, depending on how much oil you're flinging around, that oil gets scraped and it's got to get swallowed back into the piston basically. So if we remove a lot of that oil, there's less oil for the ring to worry about. You know, there's just enough, and that helps a lot. So this last little side view shows, you know, rings that are displaced. One's trying to reach out to the bore, it might be leaking oil. The top one's getting pounded into the bore because it just rocked over. So integrated skirt clearance. And then let's see, I'm having, there we go. So this slide we've used before, but it's important to have good tribology once the piston fits right. That's gonna, a low friction is good for power, low wear is gonna maintain that shape. Even though the coating is really soft, the oil film gets so good on that big footprint on the right that the wear actually stops. You know, you can run a 4,000 horsepower engine, 30 passes, take the piston out and scrape the coating with your fingernail. If it, you know, it's the oil that's guiding the piston if you create that perfect oil film. So then, you know, here's just another example. That piston on the left, you can see it's burnished more. It's a stroker motor, so you can see the little line where it was coming out of the block, but you can see the whole skirt is engaged with the bore for stabilization. And on the right there is Woody's old Pontiac with about 1% leak down using Total Seal gapless rings and a Total Seal leak gauge. But you know, basically our coatings help the Total Seal guys because it reduces the ISC and preserves the right shape. It does it quickly, safely, low cost, and it lasts. And you know, that translates into a lot of happy phone calls. And we stumbled into it, believe me. We didn't set out to you know, we were just like, why does everybody want tight pistons maybe that's a place where we can help, and we started coating pistons, and 20 years later, 21 years later, we know a little bit about why it works. But here's another one we've shown. The break-in occurs pretty quick, and then things stabilize for a long time. And then, of course, you get your power, acceleration, clean burn. Once you start burning oil, you're making hard particles up there, and then they get involved with the ring and piston motion and scratching and all that. You know, if you can seal that oil and stop those first scratches, your cylinder kit will last a lot longer. Once that kind of stuff starts to happen, it only gets worse. So let's see, I'm running out of slides here, so I hope there's some questions coming. Oh, another place you see it, hear it, feel it is vibration and noise. Whenever you hear pistons slapping, you just think about, what are my rings going through right now? And what are my skirts going through, getting pounded on? What are the bores going through? Is it my top land hitting and transferring metal? You don't want to hear slap. So, you know, and this is a depiction of a chainsaw engine we ran with and without the coating. The red one is a coated piston, nice and snug. And you can see we cut the accelerations about in half there on the right side. So that's going to help your rings a whole lot too. And then let's see, what else do we have? Just wanted to show, oh, yeah, we got a new guy coming online in Australia. The stuff is about to get on the boat. So in a couple months here, we'll have an Australian applicator, and maybe a few months, depending. We're really excited about that. Those guys wait a long time. If you're an engine builder in Australia, you got to be a long-term planner. So we're hoping to get these guys serviced quickly so they can make more races, have more fun. Let's see what else. I think, yep. Yeah, this is just a neat recent event. We got onto some really high-end engines, and the elite team, Erica's team, was nice enough to put our logo on their car for a couple weeks, and they're doing well, and we're just tickled to death to see that logo on national television. So that's about all I got. I hope there's questions, and Keith, if you've got more, I can scroll back up, whatever people want to do.
Well, I'll kind of chime in a little bit with you, Andy. A couple things that you just a moment ago you had touched on, you know, what I'll call the carbon buildup above the top ring. You know, I have a customer I'm working with right now. He's got an engine, Nicosil cylinders, and he's literally ripped the Nicosil loose on the top of the bores. And once he sent me some parts, I can look at it. He's got a rockover problem in the piston, and it's got a very light oil ring in it. It's a flat engine. And he's getting an excessive, you know, carbon buildup in this part of the piston above the top ring. Because of the rock problem that he's got in the engine, that material, as we know, that carbon is extremely abrasive. And every time that piston comes through rock over, that carbon is like a piece of sandpaper just eating away at that Nicosil, and it's finally sanded it down so far, it's so thin, it's actually starting to flake and chip off the bore. The Nicosil's fine. It's the carbon problem on the piston from the constant rock over that it's got, and it's chewing the Nicosil off the cylinder. So it all comes back down to that piston stability. And because of the excessive rock, it's trying to pick the oil rings up. And it's got a fairly light oil ring in it to begin with. It doesn't have what I'll call a lot of insurance policy built in. So because I can't share a screen per se because I'm not that smart, I drew kind of a dumb picture. What I want to call the can of beer and the keg of beer. This is your plain old cast iron piston or cast aluminum piston that's in your small Chevy or your LS. This is your current modern forged piston. They're both running 4,000 piston to wall clearance. But, you know, I've exaggerated this quite a bit. But we've got a lot of taper and a lot of cam in the piston. And this is especially an issue today with our very little short box strutted style forgings. We can get into, even though our piston to wall clearance is fantastic, we get into a lot of rock coming through top and bottom dead center. And this just, excuse my candor, it just pisses off the rings. And everything's got a problem. It doesn't have good blow by, it doesn't have good oil control. It's simply got so much rock in the piston. And I won't blame the piston guys in any way. They've got one of the toughest jobs. You call up, you order a set of pistons for your 632 stroker. They've got their, what I'll call their blend, their combination of cams and tapers, and they get that to you. Now, the one thing that comes into play significantly is, does this piston stay inside this cylinder? If I take that piston and I've got it in the cylinder, you can't really see it, but man, it's got very, very little rock. It's very stable in this particular bore. This is out of a Ferrari engine. But if I pull that engine, that piston out, I built me a stroker. I've got this. I've got a lot of piston rod. Why? Because I've moved what's called the gauge point on the piston from being in the cylinder to out of the cylinder. The piston guys don't know this. You just gave them a bore, a rod length. I want these rings. There you go. They've got the toughest job because they've got to come up with a size and a shape that works well on, just about everything. And sometimes it does and sometimes it doesn't. They need your feedback. I had one particular guy build a nitrous motor, 65 thousandths rock over. It's a long story. Dial indicator on the top, down onto the piston. He's measuring how much rock it's got side to side, 65 thousandths. This is a mountain of rock. Stock pistons generally in single digit range. It's got so much rock, it can't fix it. He wants to know what brand of piston to go buy. I'm like, no, buy the one you've been using. Call them and talk to them. Send them some pistons to look at. They can look at the witness marks. They can do these things. They can evolve this piston. You think Ferrari Formula One takes the first piston out of the box and goes, yep, it's good. No, there's a mountain of modeling, a mountain of testing that gets done to develop the right shapes, the right profiles to get that piston stability. So work with your piston guys if you got a problem. But one of the simplest, easiest ways is working with these guys. We take that problem, we apply the coating, it's going to clearance itself. And I don't want to sound like a commercial here, but this is a big part of where our relationship started with guys that they've simply got a problem with the piston. They don't have the time or the money to evolve and develop that new piston shape that's right for what they're doing. Get the skirts coated. Work with these guys. They will work with you. We'll develop the right thickness of the coating for what you're doing. It's going to wear it. I call it like this, and you guys may hate me for this, but I call it like putting Bondo on your car, man. You put it on heavy, you come back in, you work down all the high spots, fill in the low spots, and we create that perfect body panel that go, wow, look at how nice that is. This is what we're doing, and you know what I'm saying, kind of crude terms here, but we're filling in the low spots, wearing off the high spots, and creating that shape. I could go on and on and on about this. I had one particular gentleman doing a very big bore, 5 1/8 inch motor, could never, ever, ever get good ring seal in this engine. Went through multiple designs of pistons. My comment to him is like, send them to line, have them coat the whole damn thing. Top to bottom on the sides of the piston, coat the whole thing, run it, let it wear in, let it wear the coatings off where it needs to wear them off. Now you've got your model. Now you've got the shape of the piston that the engine's telling you it wants. Guess what? Best ring seal we ever had.
All right. Well, sounds really, really good. Real quick, Richard, he was wondering about, are the coatings equally applicable to cast aluminum pistons such as a 4032 or forged pistons 2618?
Absolutely.
Yes, sir. Go ahead, Mark.
In fact, we've been on multiple substrates, whether it's aluminum pistons, cast iron pistons, even though we have what we like to call an entire rainbow of black in terms of our different formulations. There's a specific one that is really the workhorse for almost all engine applications. And so what we'll do as part of the process is when you send your parts in, we like to get a little thumbnail sketch of what your engine is, horsepower, displacement, solid block, so on and so forth. And that really helps guide us to come to the, ideal target thickness. So basically what we do in these applications is look at that kind of a piston, look what it's running in, and we can adjust the coating to wall clearance, as we call it, to be able to work the best in that particular situation.
Okay, along the same line, Richard was also wondering, are the coatings more beneficial, excuse me, to short connecting rod lengths? Or is there a difference between, you know, long and short when it comes to, you know, what you get into, you know, as far as vibrations and or misalignments that you're trying to fix?
I think I know, but I'd rather hear from Keith.
Well, again, we're back to what I displayed earlier about keeping the piston in the cylinder. So rod length, obviously is going to cause more side loading on the piston. So yeah, it's if we've got a bad rod angle, a very steep, approach angle, it's certainly going to help that. But again, trying to get that piston shape right, get that stability. So, as we can, if we keep the rod like this, we don't have a lot of side loading. We get that short rod, that too short of a connector rod, we get this kind of an angle. Obviously, we're side loading the skirt and trying to drag it through the side of the cylinder wall. So there is that fine line. But yeah, I can see where it definitely would help if we've got a lot of side loading on the piston, but it comes back to if we get the piston stable, it's not as dramatic effect.
And we have another gentleman, Dale Hahn. He wanted to know from the longevity graphic, can the line-to-line coatings be reapplied, let's say after, 80,000 miles or 80,000 kilometers? And I know what the answer is, and you're going to tell them again.
Well, as Andy likes to say, we can get 9 lives out of every 10 over, because now with the coating, instead of having to bore and oversize if you happen to scuff a cylinder, just go in and hone the cylinders to where they're straight and you're happy with them. Send us your old parts with the new dimensions, and we'll apply the coating for the ideal fit. Now, in terms of reapplication, absolutely. End of the season, you go in to do your freshen up, clean up the bores again, send us your pistons again. We will strip off the old coating, reapply it to the new dimension, and you're good to go. We had one circle track engine builder many years ago when we first started working with him. He was doing his first freshen up and he said, yeah, I got to clean things up a little bit, but the pistons look great. Can we do something about that? Of course we can. Well, ultimately, he ended up sending them back to us, I want to say at least 3 to 4 additional times after every season. When he would get in, clean up the bores, we would recoat them to his new dimensions. And so he definitely got his money's worth out of that set.
Well, Justin now wants to know, when you, as far as the scenarios and guys, what he's looking for is the thrust side of the piston. Do you pay more attention to that side as far as the coatings are concerned, or is the coating equally applied to the piston and in everything involved?
Generally, we try to be symmetrical. We figure that the piston design people know what to do, and they put the pin, maybe off center, a thou or what. They're the wizards, so we try to just go even. But it's something we could do for sure. If you would like us to apply more on one side than the other, that's definitely doable.
Okay, so what about the dyno break-in process? Could you give some specifics for NHRA, comp SB class, 10.5 RPM? Is a break-in process that you guys like to see happen before you just go out and hammer it?
Yeah, this gets into a big subject. We used to coat stuff line to line, like zero clearance, and as soon as your piston starts growing, it would interfere pretty heavy, and you had to be real careful. Because if it's coming off and the piston's still growing and you're creating maybe more friction where you're squeezing the oil out, it can run away and pop parts of the coating off. So we always want to kind of kiss the bore with the coating for several seconds. As it grows, more power, more torque at RPM. Power is heat. So you have to load your engine to make the pistons grow. You can't just rev it. That's not going to do anything. But we want to, make the piston grow. Now it's interfering with the bore. You squirt the oil out of there and it's rubbing on the coating, and then you let off and your piston will shrink again. You don't have to shut the engine off. Just removing the power demand is going to allow your piston to shrink. The oil gets back up in there, and then you go again a little harder. So you keep just kind of gradually honing it off. And boy, all the different kinds of materials, all the different kinds of races. You got the 2-strokes, you got your top fuels, you got your vintage motorcycles, you got your Formula Vs. All those over time, we have figured out that, well, what we do over here doesn't really work over there. So we're in a high power application, we leave more of the intended manufacturer's clearance there. So normally now, instead of going line to line, we'll take up about 75% of the clearance that your application calls for. So if yours calls for 4 thousandths, we're going to put 3 thousandths of coating on there. After you run it real hard, real long, you'll probably have 2.5 to 3 thousandths of clearance at the end of that life cycle, instead of starting with 4 and then ended up with 5 or 6 because all that wear and everything. So it's really it's a big equation. The reason on our break-in sheet, it's more of a philosophy that your engine. If you can put half load on it and leave it there for a minute. Sometimes you can't do that. So the guys that can't do that, we have to leave more clearance. If you're not sure what to do, we can use a softer coating, and then it's going to be more forgiving, but it might not last as long. If we put top fuel type coatings on a 2-stroke, it'll never break in. It's going to stall every time you get the third gear, never going to break in. If we put the 2-stroke stuff on a top fueler, it'll probably be gone in a half a second. So it's a balance. We're happy to help, and it's getting easier because more people are thinking along those lines. It's not quite as new, but yeah, we got a question a while back about flat tappets. What should I do? I got to run it 2,500 RPMs for 20 minutes. Well, at no load, that's not going to make your piston grow a lot. So you just kind of do all that normal stuff the way you would. And then before you really pin it, if you haven't run that engine with our coating yet, then you just kind of go up the power curve and come down. And then you let it idle a minute or two, and then you go up higher on the power curve or longer at the same time, power, and let it down. And in a matter of minutes, it can be a hot lap, a couple of hot laps. The circle track guys will go, man, I could just feel that engine opening up. It was tight, couple hot laps, man, you could just feel it. So those are it's neat. But just be careful if you have a little extra time, creep up on it. And then that's how you're going to end up with the very best fitting piston for each bore. And I know Keith has recommended us a ton. He may have more insight on what to look for, listen for on a break-in.
Well, I back up what you say, Andy, and I've worked with a lot of guys on this stuff, and what Andy says, you want to creep up on it. Don't just, okay, we fired the thing up, and okay, we got 120 degrees in the water and 180 in the oil, and pin it, 11,000. That's never good for anything. So my recommendation is always warm it up, get a little heat in it, put a mild load on it, put 50, 60, 70 pounds of load on it. like Andy said, you know, put some load on it, let it run 5-10 minutes, back it off, let it cool down. Keep an eye on the color of the oil. Most of the guys that I work with use the soft coating. They're just, you know, they're trying to get a little stability. They're not trying to make it last, you know, 80,000 miles. They want to go 50 runs. That's it. You know, it's comp stuff, super stock stuff. So they're generally using the soft coating. And I tell them, you know, keep an eye on the color of the oil. You know, as that coating starts to shed and starts to wear, you're going to see the oil color kind of change. It's going to get a little darker. Once you see that kind of level out, you're pretty much good to go. Change the oil, away you go. But kind of ease into it. You know, a couple different steps, kind of stair step your way up to it. Take your time. And one thing I'll say from, you know, and if Lake was here, he'd chime in. You know, all of this, you know, wearing the coating in is very important, but it requires friction. We gotta have a little friction. We gotta make the engine work. We got some heat, some load, a little bit of friction. If I put, you know, the slickest ester-based wazoo synthetic in there that's cutting friction, guess what? It's not gonna wear in very quickly. So make sure you use a proper brake and all while you're doing it.
Yeah,
Very good. While we're talking about the coating deal, Lover Katame wants to know, how are the coatings applied? Is it liquid? Does it have a robot apply them? If not, how are you able to be precisely applying to the correct coating thickness?
Yeah, actually, they are not liquid. It is powder, which coincidentally is proprietary. We developed the formulations. We actually manufactured in-house. And without going into too much detail, because not only is it the powder, but the application process that's more or less proprietary or trade secret, but we can put the coating on. In the instance of a piston, for instance, we have a tolerance of what we say is plus or minus half a thou diametrically. So it's just been through many, many years of trial and error and development that we've been able to get the process dialed in enough that we run, well, like Andy said, we came up on job number 10,000 here this week. So we have a lot of experience doing it.
Yeah, and it is a high volume process. We have it semi-automated. I wouldn't call it a robot, but we built a machine that gives us good control of how much material we're putting on. And that was quite a trick. And that runs at about 13-second cycle time. So it is really scalable. The UEM guys do pallets of pistons, and so we've tried to cover a range. You know, it's funny because when we first started doing piston, we started off on superchargers and OEM, just making the coating and shipping it to factories. And when we got into pistons, we thought, boy, it'd be nice to do millions of pistons, and that's why we picked it as an application. Where did they spend a lot of money in aggravation working on clearances? And we could maybe save a lot of trouble on that application. So 5 short years later, we actually had a coating that would stay on the pistons at a good power level, and we started selling it. And that was in 2008. And boy, we were pushing on a rope for a long time. You know, back then, a lot of guys would say, well, I'm not honing the block until I have the pistons. And we're telling them, no, hone your block and we'll make your pistons the size for your block. That way, you know how much you got to take out to clean it up, etc. And so anyway, yeah, it's been a lot of fun. We have stripped and recoated a whole lot of pistons in our history. We don't do it as much anymore because we're pretty good at it. Another thing is you can Scotch-Brite this stuff. You know, sometimes if we're a thou heavy on you know, we're looking for 9 thou, comes out of the oven, we got 10. We can Scotch-Brite it down till it mics the way we want. And that works great. There's a little bit of a fuzz layer that about a quarter of a thou, 2.5 tenths to maybe 4 or 5 tenths of really soft fuzz. That comes off pretty quick. We've got one customer out of many hundreds that he won't let us, you know, abrade it. He says that that little bit is part of my break-in that I know. So we have to peg his, but you know, if you're not sure what you need, you can always touch it up with the Scotch-Brite. So we try to aim a little heavier, bring it down, and it'll still break in properly.
And Andy, real quick, you know, with a lot of the questions we're getting now, and I know there's going to be more to come. Where do they need to reach out to be able to talk to you, you know, give you a call and get more information? I mean, what's the best way to make contact with you to find out whether line to line is what they need for their project?
All of our guys, Brian down in South Carolina, he knows a heck of a lot more than I do about engines. But yeah, we've got some videos we're actually launching. Sorry, my other phone is ringing.
Yeah, that's
but we've got some videos that we put. Mark is loading them right now. 3 or 4 are up, and there's a lot of info, but call us. Yeah, we're on the web. You can just call the shop and we will spend the time to make sure you're headed the right direction.
Also, there's a lot of information at the website with technical papers and an FAQ page and so forth. I'd just like to touch real quickly on one question that came up here regarding PFAs or PTFE. Zero. We've got none. So it's all environmentally friendly, no VOC or low VOC stuff. So use it without fear. And we're going to be around for a long time, just as I'm sure Total Seal has been and will be.
Yeah, and let's not miss this last question from Richard. Shifting gears a minute, he says, parkerizing camshafts is the only option to ensure survivability of a flat tappet camshaft. Has anyone thought about how your coatings could be applied to that camshaft technology?
Yes. The short answer, yes. That conversation's been going for 6 months. We haven't done anything, but yeah, we can coat a camshaft in a sacrificial type coating. And we'd love to try it. We just haven't, it's not our wheelhouse, but we can coat anything that fits in the oven. Just need your feedback.
Yeah.
You know.
Well, guys, you got it right there straight from the guy's mouth. That, you know, just give us a call. We'll give it a try. And when you talk about in the oven, the question I got, Judy, have you made a birthday cake yet? What have you got in the oven? We would all like a slice of birthday cake today on our birthday. How about that?
We have received a lot of comments on our newsletter that went out this morning. Cool image. So, but no.
Okay. Gentlemen, thank you for your time. I appreciate it. I enjoyed it again, as always.
Thank you, Jeff.
Thank you, gentlemen.
Thank you so very much. Appreciate being part of it.
Thank you so much, and thank you for stepping in last minute. And the original webinar on diesel piston with UEM will be rescheduled again later this year, and I'm sure Keith and Andy and Mark will be part of it because they were the special guests. So thank you so much. This webinar has been recorded. It will be posted later on the ePartrade platform, distributed through our newsletter and social media channel. For more information and updates, please visit www.ePartrade.com. Next webinar will be on camshaft and lifter with Elgin. Thank you very much and goodbye.
ePartrade is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePartrade, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
ePartrade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
Where will you find Ferrea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Ferrea Racing Components. Stand with us or race against us.
Scribner Plastics has provided professional strength shipping containers to the automotive and performance industry for over 40 years. We have containers that will fit most any configuration of complete or partial engines and transmissions. Today we highlight part number 5148 cylinder head shipping and storage container. Base has double-walled durable construction featuring a cinch strap with an abrasion sleeve that securely fits your small block, big block, and pro stock heads to the base at all times. Talk to your dealers and distributors about the shipping storage container for cylinder heads from Scribner Plastics, part number 5148.